In this lecture, I want to cover a topic of the Diels-Alder reaction involving the stereochemistry, which is called the Endo Rule. Now, what the Endo Rule says, well, first of all, it's got a lot of definitions. I'm just going to give you kind of my verbiage or articulation of the definition, which is going to have some vagueness to it, but I think is a little bit more helpful at the end of the day. That is, the dienophile, which again is our monoalkene. The dienophile orients orients itself so that its bulkier groups, bulkier is not a great word, bulkier groups are down or within, let's do this, within the forming ring. Now, all of this is in the context of the Diels-Alder reaction. So during a Diels-Alder reaction. Okay, so let's first of all attack this from a general stereochemical model. Now, what I'm saying is that its bulkier groups are sort of like its stuff. So let's take a diene, but let's keep the diene boring. If the diene is boring, let's consider things on the dienophile. What I'm going to do is I'm going to put H's on one side of the dienophile and then put sort of stuff on the other side of the dienophile. And we'll have the stuff be cis to each other. So this would be a Z alkene or a cis alkene. Now what I'm going to do is I'm going to do the Diels-Alder reaction such that the stuff is first of all cis to each other, but also down. So the stuff is first of all cis. Now I know it's cis in the alkene starting material. I'm going to go ahead and use Z there because cis here implies that it's on the same side of a ring that is formed. It's cis in the ring, but more importantly, it was positioned underneath the forming ring. Let's go to our sort of perspective drawing, which accounts for why the Diels-Alder reaction happens at all, where I'm going to have my diene drawn with perspective. And now my dienophile is shown down here. Now my dienophile is going to have now 4 groups attached to it because it's now the exciting piece. If we consider the ring forming this way, what it looks like we have is we have kind of 2 sides. We have this side that I'm going to highlight in green, and that's these are groups outside or exiting the forming ring. So these groups are pointing out and away from the forming ring. That's in contrast to the other groups that I'll highlight in red. These red groups, these are underneath the forming ring or within the forming ring. Okay, it's these groups that are underneath or within the forming ring. These are called our endogroups. And these are groups on the dienophile that are positioned within or, quote, entering the forming ring. So these groups are said to be entering the forming ring, and that's where this entering word is what we use to kind of come up with endo, entering. Now, conversely, if they're exiting the forming ring, they are our exogroups. Now, this is only on the dienophile. This is only on the monoalkene system. And we say that on this monoalkene system, there are both endogroups and exogroups. Now, the Endo Rule, I'm going to restate with this context. The Endo Rule says the larger groups tend to be endo in a DA reaction. Okay, now let's go back to our perspective drawing and think about why these two groups are both down, both dashes, and are cis to each other. Well, okay, if we've got our Diels-Alder diene and we've got the dienophile, what I'm saying is we're going to position the stuff kind of inwards on the ring or underneath that ring. And so here are my bonds showing that things are being formed. And then the H atoms are positioned outward or exo. These are my exo groups because they're exiting the forming ring. And the Endo Rule says the stuff should be endo. So for most Diels-Alder reactions, we position the big stuff to be endo. That's the Endo Rule. Okay, so orienting and arranging our dienophile is critical to understanding the stereochemical outcome. Once we have this arrangement, we can do our Diels-Alder reaction. So there's our ring with all of the bonds being formed, and now we need to add the stuff to it. This gets crowded. Stuff looks like this. So what I'm going to do is highlight in green the two carbon atoms I need to consider during this unfolding process. So what I'm going to do is, before we had talked about taking the corners and spreading them out when we relax and unfold. Here, though, I'm going to worry about picking up the green carbons and pulling up on them. So I'm going to pick up the green carbons. I'm just going to pick them up and yank them upwards like this. So yank the green carbons up. So it's kind of the atoms, the molecule starts like this, where here are the green carbons. I'm just going to pick them up. And when I pick them up, the hydrogens, which are firing outwards, the hydrogens are going to launch up and be our up groups. So the hydrogens are going to both be up in this case. And then the stuff that's pointing in, as the molecule unfolds, my stuff is kind of pointing inwards. As my molecule unfolds, now my stuff is going to be pointing downwards. Relax and unfold. And then the stuff is pointing down, which we show as a dash, whereas the hydrogens are pointing up as wedges. Okay. So we can use the Endo Rule to help us figure out what the stereochemical outcome will be, what the major diastereomer is for Diels-Alder reactions. And we're going to focus, and it allows us to focus on the dienophile. So, excuse me, sorry. So if I'm more specific here, let's go ahead and consider a Diels-Alder reaction. Let's go ahead and consider a Diels-Alder reaction where we mix this with this. Okay. So first of all, what we can recognize is we've used things with groups sticking up and sticking down, or things that are E on the diene. So just from our general stereochemical model, and we'll prove this with a three-dimensional perspective drawing that we've gotten used to, we already know where those groups are going to be oriented. I guess it would be productive for me to draw the product without stereochemistry first. You always start by making sure that you can draw the cyclohexene product, methyl group, chlorine atom, chlorine atom. It's meso, which means I don't have to write plus enantiomer. I mean, I could. That's not what I want to test you guys on right now. But this is a meso molecule because it's a plane of symmetry. But still, we have to define the relative configuration, whether something's wedge and dash, respect to each other in the product, with respect to each other in the product. And that's where we use our general stereochemical model. Now, what I was alluding to was based on previous lectures that focused on the diene. We already know that according to our stereochemical model, and I'm just going to write right over the lines here, we already know that the methyl groups are going to both be down or dash because they're sticking out of the ring, which as you kind of unfold the ring, those methyl groups fire downwards. Okay, that's a past lecture. But now what about the chlorine atoms? First, what we want to do is redraw the dienophile to follow the Endo rule. When we redraw that, we get to a perspective drawing. Oh, excuse me. The perspective drawing is upcoming. Yep. Sorry. We're going to put the stuff facing to the left as though it's underneath the forming ring. So this is an endo orientation. I've just literally flipped that over so that I can put the smaller stuff over here to be two H's. Now I'm going to consider a perspective drawing. Here, here, here. So the chlorine atoms are going to fire underneath the forming ring, whereas the H atoms are going to be exo and exiting the forming ring. If I redraw this perspective drawing such that I now have proper bond formation, put a chlorine atom here and a chlorine atom here. Got my H's sticking out and exo. My chlorine atoms are oriented endo. And I'm going to emphasize that. So we have endo orientation here on the chlorine atoms. Because the chlorine atoms are bigger. They are our stuff. So now I have endo orientation. And so what I could do then is connect the bonds, which I've done in this bottom structure. And if I unfold and relax the geometry, first of all, I need to draw my methyl groups. My methyl groups, as I alluded to, are dashes because they're both pointing out. And as we pick up and unfold the corners, those methyl groups are going to spin down. But unfolding the corners, that was what we focused on for the diene. Now I'm at the dienophile, and what I want to do is just take those green atoms and pick them up as I unfold the corners. It's best to just focus on one aspect. Focus on the corner unfolding first, and then walk over to what I've highlighted in green here, which are the dienophile atoms. Pick those up and just bring those up to flatten the structure and relax it a bit. In this case, the chlorine atoms are facing inwards, so as you pick them up, they're now going to be facing downwards. And this then becomes the major diastereomer. And it's important that I write diastereomer. That tells me, kind of reminds me that, okay, if I also have the structure with all wedges. In this case, they're the same because it's meso. Don't worry about meso this time. But it's a product of the teaching. You'll see a lot of meso structures in this unit, but don't worry about that. Okay. So what we could do just to finish this off is just, well, no, I'll save it for the next lecture. But there's a lot of practice here. In general, when we draw the products of Diels-Alder reactions, I want you to draw the endo product as the major product. So when I say provide the structure of the major diastereomer, typically I say also the major endodiastereomer. Next time we'll kind of look at why this is the case, why the Endo rule works the way it does. We could look a little bit at the exo product. I don't want to call it the exo rule, but we could just draw a few exo products to maybe help you differentiate between endo products and exo products. But there is no exo rule. There's the Endo rule. I mean, I guess somebody could probably define an exo rule somewhere. For us, though, right now, let's just focus on the Endo rule. Okay, anyway, we'll see you next time.